then by doing these repeat surveys, we can track how the site has changed over time. And then bringing it into the GIS, do some digitizing. So in this one, we have traced kind of I call it like the slump scar, which is an older slump that's not changing, and then the active slump where we are seeing active thaw and material moving out, and that is the part that is growing and continuing to grow year after year. And then this is that other site, Peninsula Point, and we can see the difference from 1967 to 2018 here. So this is a site where there's both that permafrost-driven erosion and thaw, and then definitely also some coastal erosion happening as well. And then when we get in and digitize the edges over the 4 years, we can continue to get a picture of the erosion and then start to do some analysis. So this was a digital shoreline analysis tool set by the US Geological Survey. So you can basically run through their algorithm and calculate net change or linear regression rates, and see how much the shoreline is changing, and is that like growing or shrinking. So this is a dramatic site where at kind of the furthest change area, it's 400 meters of shoreline loss. Oh yeah, and here is an image of that quarry, one of the quarries outside in Nuvik, where again we're working with other groups to keep track of their stockpiles. Which brings me into the partnerships and training. So that's another big element of the Aurora Research Institute's drone program, is we're building capacity and providing drone training. So we've worked with the Inuvialuit, their Community Economic Development Organization, ICEDO, also the Inuvik Community Corp, and then this summer we're working with the Gwich'in Tribal Council to train drone pilots in each of the communities in the Inuvialuit settlement region and the Gwich'in settlement area. So building capacity and helping get good, reliable, and safe drone pilots out there. So just some photos for that. The drone courses, we try and make them fun, but it is a lot of classroom sitting, learning all the drone laws and the policies and procedures before we get out and actually start flying. But then we also make sure we get out and do a lot of practical drone training as well. In some cases combined with other science capacity building. In this case, it was combined with permafrost monitoring and ground temperature monitoring. So we were installing thermistors to read ground temperature. And then, in other cases, it's just strictly focused on the drone flying. So getting out, practicing. And then for some groups, we look at I would say it's not an advanced license, but it's advanced drone flying, in that we're flying with the aim of collecting scientific data and for mapping. So we're teaching how we do the surveying element, installing those ground control points to make sure that the data we're collecting is locationally accurate, and then planning our mission so that we're able to collect data that's able to be processed properly, so we can make those maps. Yeah, and this one I can kind of skip over. Yeah, for 95% of drone flying, In our region, you only need a basic license. It's just these little red circles are where you need that advanced license. So for most of the work, you don't need it. Yeah, so this is just a video of one of the sites where we've got our surveying set up. We've installed ground control points. We're flying that fixed wing drone and then also a multi-rotor drone at the same time. So documenting the site from multiple methods. It's very choppy, sorry about that. Yeah, and just a view of some of the gear we have to haul out. So, I mean, the drones, they are pretty portable, and some of them more than others, but when we're doing the full kind of site survey and doing it for mapping, we do have a lot of gear to haul out. So, it's nice to be close to a road where we don't have to walk too far into the bush. Documenting the ice road breakup. And then another group that the Aurora Research Institute works with a fair bit is the Geological Survey. So this is, yeah, again, where a lot of that permafrost landscape change comes in, where we're documenting permafrost features and then also tracking change. And just some of the other stuff we do with drones is then creating outreach products with that. So we're collecting the data, but then we also want to share the data. So this is just a quick example of the actual site, and then the model that we created with the photogrammetry software, and then further edited into a nice little visual that we have built into a story. We've got another one of those with different slumps up in Olivec National Park. And then a edited GIF as well. So the outer, the kind of edge of the slump, or sorry, yeah, the slump head wall, and the top is from the drone derived model, and then the rest of it is edited with photo editing software to kind of create this visual product showing an ice wedge. And we'll take a look at that if we have time, but it's just more kind of visual examples of the stuff that we're doing with drones and how we're sharing it. And yeah, our last partner that we've worked with a fair bit is Parks Canada. With them, we're mostly just helping them with the drone flying, and then they're doing the analysis work on the back end. But yeah, there's work being done with parks looking at vegetation, cover and classification, looking at archaeological sites, and how the landscape around them is changing, and then looking at permafrost change in the parks as well. So lots of different projects, mostly environmental based. There's many different uses of drones, but that is primarily what we use drones for at the Aurora Research Institute. So now I will turn on this drone, and while I do that, yeah, if anyone has any questions.
So all the pictures you show of the melting Arctic.
Yeah.
You've been there a while now, and if you put it on a timeline, the break talks about how much more intense it is in the Arctic, how fast things are melting.
Yeah.
And looks like you must be seeing that everywhere you go.
Yeah, I mean, we're going to the sites that specifically have a lot of that change happening, but that combined, let me pull up, I will pull up that story map because that looks at that kind of specifically. Oh, you just use mine. What's happening with Chrome?
I don't
Okay.
use this laptop often.
No, okay. Alright. So yeah, we're combining the drone with kind of bigger mapping projects where we're looking at satellite imagery, historic, seeing how it's changing to kind of target into hotspot areas, as well as talking to people, cause you know, generally people that grew up in the communities will know where kind of the greatest change is happening. That's how they selected the sites along the Cook-Mallet Bay coastline, is by getting feedback from the community. But yeah, I think I'm not a permafrost person, but I think what can generally, the consensus is that, you know, these slumps and permafrost change has always happened, but it's happening in increasing frequency and an increasing size, and it's not stabilizing the same way. So we're seeing more of it happening, basically.
The town of Fort Smith is using drones and LiDAR to track the shifting of the landslide zone.
You need an advanced license for that, cause it's close to the town.
And that's
airport.
why they hired a super company.
So we'll just look at this super quickly, but basically this is a bigger mapping project that the Northwest Territories Geological Survey is leading, but ARI is a partner on, where using satellite imagery, we've basically mapped the entire territory. This story is just focusing on the Western Arctic, but for those slump events. So basically every square you see that's yellow, that's a 7.5 kilometer grid cell where one slump was seen in the satellite imagery. Orange is between 2 and 10, and red is more than 10. So this has been used to kind of validate the hotspots that people are seeing. So we can see like the Richardson Mountains and the Tuck Peninsula have a lot of slumps, and then Banks Island as well. So this is Olivec National Park here, where a number of slumps are happening. So yeah, then from there, if there's slumps of interest, those are kind of targeted sites to go and fly at. This is another drone imagery product where basically it takes, I think, 36 pictures in an array, and then stitches that together into a 360 image viewer. So you could put this in a VR headset and then basically look around as if you were looking at the slump in person. So that's something else we like to do when we get the chance. Let's create that. I'll keep this up, but for now we're gonna test this out. We're gonna switch to this camera, if we can, and take a look at the thermal camera on this drone. So I'm sorry, you're gonna be right in focus, but I'll move it around. So
Quick, can I have your consent to be on our video?
Sure.
Thank you.
So this drone has a number of different cameras on it. We've got what's called the first person view camera, or FPV, which is basically it always sees what the drone is seeing forward. And if I...
There's just a little pop-up on the screen. Fix it for you.
Oh yeah, okay, thank you.
Yeah.
And we can see with this camera, when I move side to side, the whole image moves. And that's because it's the camera that's mounted on the body of the drone, whereas you guys can see the camera on the gimbal it's kind of like a chicken head, if you've ever seen people do that, where it stays stable and locked in. So I'll switch to that view now. So this is our other camera, and it's more powerful. We can also zoom in and switch to a zoom camera. So
Nice nails.
it's a pretty powerful camera. Here, I'll look up above, and I'll continue to zoom in. So that is an 80 times zoom. So it's reading the text on that little corner of the screen there.
Whoa.
So yeah, pretty powerful zoom camera.
Is this how you would like check for like solar panels? Like where is this
So
be able to zoom in and stuff like that?
yeah, for the solar panels, you'd want to have it on the thermal camera because you want to see how efficient it's transmitting heat. So I'll switch to that right now. So this is our thermal camera. We have it in a color fill view right now, but we can kind of switch back and forth. And this is giving a live heat reading. If you can see where the target is right in the middle, it's telling us the reading. So it's telling us that that's 19 degrees. But if I move it over to the window, let's say, yeah, it's giving us a read of, it's dropping, but 6.6. And then if you move to someone's face, it's 35 degrees. So it's not, it doesn't claim to be like 100% accurate, like not diagnostically accurate with temperature, but it's really good for giving a comparative temperature reading of a site. So it's good for detecting thermal anomalies or hot spots. It's great for seeing things, I mean, that we can't see. I'm looking around, I don't see, sometimes I can see like hot water pipes running through walls. Let's see, I think that might be the kettle. We'll switch over. Yeah. Kettle blocked by the propeller a little bit. So yeah, there's, you know, quite a number of different applications of this drone as well, beyond kind of just taking pictures and videos.